In this video, we will see moment area method. So, it is given by two theorems given by Morse. So, Morse's first theorem is theta A minus theta B will be equal to area between AB upon EI. So, if you see this theta is a slope at point A, theta B is a slope at point B. The difference between both the slope will be equal to area between the AB in the bending moment diagram. So, we have to plot a bending moment diagram for particular beam, and then we have to take area between A and B in the bending moment diagram divided by EI. So that will be the difference between slope at A minus slope at B. If slope at B is 0, then we directly get slope at A. The Moore's second theorem tells us that y at A minus y at B means deflection at A minus deflection at B will be equal to AX bar upon EI. So here AX bar is area is the same area between A and B in the bending moment diagram. X bar, if you see X bar, this is a centroid of area that we are talking about. So area which we are getting between A and B, we have to take the centroid, and then we have to find the distance from one of the point. So centroid of area from one point, so distance of centroid of area from one point, and the other point which is remaining, we have to take the tangent from that point. So we have to remember these 2 points, we will use it. So we have 2 points A and B. So from one point we have to take distance till the point of centroid. So x bar is a distance, which is a distance from centroid of the area from one point, let's say A point. Then we have to draw a tangent from the B point. So these 2 points we have to remember. You will get more idea if we discuss in the example. So this is critical for this example. So theta A minus theta B is area divided by EI. Ya minus yb is area times the distance divided by EI. So this distance is distance from one point to the centroid of the area that we are talking about, and the remaining point we have to take the tangent from that area. So now we'll discuss how to implement this process. So here you see we have a cantilever beam with a point load at the end. So this is the bending moment diagram. If you calculate it, you will get WL moment at here, maximum moment. You will plot this, you will get this bending moment diagram. So now if you see the deflection curve, so deflection will be like this. So now we have 2 points A and B. I am taking B point tangent, so tangent from the B point. So this curve, I am taking the tangent of this deflection curve. So now we have to take X bar from A point. So from A point we have to take distance till the centroid of the same area. So we have A and B point. B point I have taken the tangent, and for use of A point will be from A point I have to take moment area, means I have to take the distance till the centroid of this area. So like this um, I used to implement it. You can do it in other way also, but this is a much better way to remember. One point we have to take tangent of the deflection curve, one point we have to take the distance from the centroid of the area. Now we can implement this both formula. So first we have to calculate theta A minus theta B. So slope at A here minus slope at B. We know slope at B is 0, this tangent. Now if we see equal to area upon EI. So area is simple area of this, which is half into L into WL, area of bending moment divided by EI. So we will simply get this WL square by 2. We know that theta B is 0. That's why this formula WL square by 2 will be equal to theta A. So slope calculation is easy. We now look at the deflection calculation. So for deflection, if we see Ya minus Yb, so that will be equal to this thickness A to B. So we'll not directly get a deflection, but we'll get the difference between A to point B. So what is the deflection distance at point A and what is the deflection distance at point B? We get the difference. So I call it as TAB. So Ya minus Yb equal to TAB. Now we know this formula, AX bar by EI. So A we know half into base into height of this area. and x bar is, I have told you, a to the centroid. So a to the centroid distance is this. If we see 2l by 3 distance, because total is l, we know centroid of the triangle is at 2l by 3 distance from this one point. So 2l by 3 is the x bar divided by ei. So we directly get wl cube by 3i, because yb is 0, deflection at b point is 0. So this is how we have to apply. And if this is only one area, if you have multiple areas and multiple different shapes areas in combined, and between a and b point, then we directly calculate ax bar as, that will be equal to a1 x1 plus a2 x2 plus a3 x3, like that we can calculate directly. Now we'll look at one more example. Here if you see, we have the simply supported beam, we have point load at the center, we know the deflection curve will be like this. So I am taking tangent at b point, similarly as first problem. So the other point which is remaining, I have to calculate x bar distance from that. So this is the bending moment diagram. So maximum bending moment at wl by 4 at b point, the half distance is L by 2. Now theta A minus theta B, we know area upon EI. So area we know directly between A to B. So between A to B, half into base into height, we can directly calculate divided by EI. So that will be equal to WL square by 16 EI, because theta B is a 0. We know theta at B is 0. Tangent is horizontal. Now YB minus YA, which is this particular distance TAB, difference between deflection at A point and deflection at B point. So deflection at A point is 0, so we'll directly get deflection at B point. Now to calculate AX bar by EI, so A we know half into base into height between this A to B. Now to calculate this distance, we know we have taken tangent from B point, we have to calculate x bar from A point. So x bar from A point till the centroid of this triangle, which is A to B. So area, centroid of the area between A to B. So that is this AB distance into 2 by 3. So 2 by 3 into AB distance is L by 2 divided by EI. So YB will be WL cube by 48 EI. So this is how we have to calculate. It is much easier if this technique is much easier to calculate if there is a random point in between. Let's say somewhere here randomly they have given in the question and we have to calculate slope or deflection, then we directly calculate, because we have reference point A and C where the deflection is 0, and we have B point where the slope is 0. So directly we can use this formula, and it is very useful method to find directly any value at random point. So this was it for the video. Thank you for watching this video.